Hi, today we're going to do BJU Press Pre-Algebra section 4.7. It's titled The Real Number System, and the homework begins on page 208 of the book. Okay, so numbers 1 through 20. Number 1, draw a Venn diagram that illustrates relationships between the 5 sets of the real numbers. Okay, so this is going to be actually found in your book. So let's go through it. This is on page 205 is the Venn diagram that they want us to draw. And let's just pretty much copy it from the book. So let's draw a big square to start. And we're going to split it into 2 parts. So the 2 parts, well, hold on, first of all, the whole thing is the set of real numbers. The 2 parts that real numbers are split up into are the rational numbers, which is labeled by Q, and the irrational numbers, which are labeled by Q prime. Okay, Q prime is a whole bunch of random numbers that do not that have decimal numbers that do not ever end. They just go on and on and on and on and on forever. And they did give you a bunch in the book right there, but they didn't ask us to write examples, so we don't need to do that. So inside the rational numbers are a few other sets of numbers. So let's just show that with the big circle. The next one inside here would be the one that looks like a crazy Z. That's the integers. Integers are positive and negative whole number. Positive and negative whole numbers. And then inside that would be the whole numbers themselves. That's just anything that's 0 and a whole number, 1, 2, 3, 4, 5, etc. And then inside that would be the natural numbers. Okay, number 2. Why do we classify numbers? Select all that apply. A, to group numbers with similar characteristics, yes. B, to compare numbers, yes. And C, to help define the properties of numbers, yes. So we group numbers for all of those reasons. We classify them for all of those reasons. As specifically as possible, classify the set each number is in as natural, whole, integer, rational, or irrational. So number 3, the number 406, this is a natural number. Number 4 is -2. This is an integer. Number 5, 0. This is most specifically a whole number. 6, 0.3 repeated. Repeaters are rational. Number 7, -4/9. Don't let this one trip you up. It's not an integer just because it's negative. Because it can't be a fraction and be an integer. So this one is a rational number. Number 8, the square root of 6. If this is not a perfect square, which it's not, then it's not a rational number. It's an irrational number. Number 9, -8/2. This one, again, don't let it trip you up. This is actually the number -4, which means this is an integer. Number 10, 12/4. Again, don't let this trip you up. This is actually 3. That means this is a natural number. State whether each statement is true or false. Number 11. Every natural number is an integer. True. You can see that by looking at our Venn diagram. Natural numbers fall inside the integer circle. So every natural number is an integer. Number 12. Every integer is a rational number. Yes, it is, because the integers, the z's, are all inside the Q, the rational number. So this is true. Number 13. There is a whole number That is not a natural number. Yes, it is. There's only one, and it's 0. Number 14, every square root is irrational. This is false. For example, the square root of 4 is 2, and 2 is a natural number. Number 15, 0 is neither rational nor irrational. This is false. 0 is part of the whole numbers, which is inside the Q, or the rational set. Number 16, if a number is rational, then it is a real number. True. That is true because rationals are Q, and that is inside this whole big set, which is the real numbers up here. Number 17, every real number is an integer. False. Wow, false. All the real numbers, every real number is everything that would be a Q naught, all of them. So number 17, every real number is an integer, is false. Number 18, any ratio of two integers is a rational number. This is false. I'm thinking the one that they would say here is 0, because the ratio of any number and 0 is undefined. For example, 0 is an integer. So if you have a 0 in the denominator and you have a 2 in the numerator, this would get you undefined. And that is not a real number, rational number. Number 19, the square root of 7 is an irrational number. This is true. Number 20, 0 times the square root of 3 is a whole number. This is true because that is 0. All right, moving along, we've got 21 through 45 odd. Number 21, as specifically as possible, classify the set each number is in. Number 21, 2.56. This is a terminating decimal. That means it is a rational number. Number 23, the cubed root of 3. So can we find a number times itself that equals 3 times itself 3 times that equals 3? Do we have a perfect cube root? We don't. That means it's irrational. Number 25, the cube root of -8. This happens to be -2. That means it's an integer. Number 27, -2/3. This is a rational number, Q. Number 29, pi. Pi is the number 3.14, blah, 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 blah. It's involved with circles. If you're not familiar with it, it is irrational. It goes on and on and on forever. 31 is 22/7. This is rational. Number 33, identify the property or properties illustrated by each equation. Number 33, this is commutative property. Commutative property of addition. All we did was switch the order that those two numbers were being added. Number 35, 5 pi plus 0 equals 5 pi. So anytime you have a number and you add 0 to it and it's the same thing, that's called additive identity. Additive identity property. Number 37, -2√7 plus 2√7 equals 0. It doesn't really matter what the two things are that are being added together. If it equals 0, then it's always the additive inverse property. If it's, I should be more specific. If it's the opposite, if the two numbers are opposite, a positive and a negative, and it adds to 0, then it's the additive inverse property. Number 39, Negative 2/3 times negative 3/2 equals 1. This is the multiplicative inverse. Multiplicative inverse property, that's when you have reciprocals. Number 41. 2 root 3 times negative 5 equals. And then it looks like they just switched around the negative 5. So they switched the order of it, even though it's all the same numbers. So this is the associative property. Also looks like they moved the parentheses. Okay, so this is two properties applied together, associative and commutative. Associative and commutative properties of multiplication. And 43. Okay, this one I can clearly see the order is changed in which they want us to add. So they first grouped the square root of 2 and the square root of 3, and that's still grouped on the right side. So they just switched whether the square root of 5 was at the end of the parentheses or the beginning of the parentheses. So that means they just switched those two. That's the commutative property of addition. What else? 45. Identify whether each statement is a proper or improper response to the power of mathematics and our ability to develop mathematical systems. Letter A, mathematics is solely the creation of human reasoning. Well, that is not a proper response. So improper. We know that mathematics was set in order by a God, our creator. Letter B, mathematics displays the wisdom of God in all his creation. Yes, this is a proper statement. Mathematics can determine objective truth. This is improper. All right, after number 45, we're on to 51 to 60. Number 51, evaluate each expression. So we have 2 times negative 12 cubed minus the square root of 289. Okay, negative 12 cubed is what we have to do first because it's an exponent. So we're going to keep this 2 out front. We're going to have a 3 negatives, which is going to keep it negative. And 12 cubed is 1,228 minus the square root of 289 is 17. So now if we multiply, we're going to end up with two numbers that have the same sign, which means you're going to add them together and keep the sign. So negative 3,473 is our answer. 52. Okay, be careful. Make sure you take your time copying this down. Lots of brackets, lots of parentheses. Make sure you keep them all organized nicely. It's very important. Probably the most common error in this type of problem is not copying it correctly to start. After you do that, then you have to be able to decipher which part are we going to do first. So you always go to the innermost parts and work on those first. So I'm going to do this and this. So I'm going to have 3. Keep all of these parentheses in here just in case. We're going to end up with 4 minus 7 plus the cube root of 8 is 2. We can take care of that right now. But here we need to do 6 minus, and we need to do 2 squared first because that's got an exponent on it. All right, again, we're not done inside the parentheses. Let's do these next. So keep this 3, big brackets. This is going to be negative 3 plus 2 times 2. So 3 times negative 3 plus 4, which is going to be 3 times 1, which leaves us with 3. Number 53. Write each phrase as an algebraic expression. 4 less than, so minus 4, twice a number, 2n. Number 54, the square root of 4 more than, oh, I'm sorry. I thought it said the square root. It says the square. Okay, the square of 4 more than a number. So you have to do the number plus 4 and then square that. Number 55, solve each inequality. Jot this down here. All right, here's my inequality. I noticed that the left side has some like terms. So before I do anything from the left to the right side of this inequality, I need to clean up my like terms. They're on the same side, so I just go ahead and add them. So it's negative 7y plus 9 is less than negative 19. Now we're going to start bumping stuff to the other side, which means do the inverse. So you have negative 7y is less than negative 28. Divide both sides by negative 7. So y, flip it, is greater than 4. Number 56. Negative 5 times the quantity x minus 6 is greater than negative 60. Let's do the distributive property first. Negative 5x minus negative 5 times 6 is greater than negative 60. This is going to be negative 5x plus 30 is greater than negative 60. Minus 30 on both sides. Negative 5x is greater than negative 90. Divide by negative 5. X, flip it because we divided by the negative. X is less than 18. 57. Compare 8/15 to 11/20. We need like terms in order to be able to compare. I'm sorry, we need like denominators in order to compare. So denominator that we're going to go for is 60. If you find the least common denominator, you'll find that it's 60. In order to get from 15 to 60, I need to multiply by 4. That means I need to multiply my numerator by 4. In order to get from 20 to 60, I multiply by 3. That means I multiply by numerator by 3. So 32 and 33 is what I'm actually comparing, which means I'll have a less than symbol. Number 58. Convert 0.18 repeated to reduced rational form. Okay, so we're going to say let x equal our repeated decimal. Then we're going to multiply by 100 on both sides because the repeated decimal was 2 places, which gets us the 100. Then we're going to subtract the first equation from the second equation because that will cancel out our repeated decimals. That'll leave us with 99x equals 18. Divide both sides by 99. So x is going to equal 2/11. 59. What is the unit rate for making 63 cars in 2 days? So 63 cars divided by 2 days, it's going to end up being, let's see, 63 divided by 2 is going to be 36031. Bring down that 0, so 31.5, which is not any of these answers, so E. Number 60, which proportion is equivalent to 3:5 as x is to 15? List all the correct answers. Okay, well, A, I just wrote down, so that one would be there. B would not be correct because the 15 and the x, that's the wrong order. C, 3 is to, yeah, that one would work. C would work. And 3 is to x as, yeah, so D would work as well. Okay, homework done. Thank you.